Okay, question 19. Let's begin on this, please. Okay. So how to find the value of A and B in each of the given equations. So you're doing a bit of a surd here. So a bit of practice on surds. Let's say the A one. So we have A plus 3 root 2. And 3 minus 4 root 2, they say is given as equals to negative 18 plus B root 2. Negative 18 plus B root 2. So the first step in this kind of equations, what you must do is we just multiply it out. So surds, so 3 times A like that. This arrow means multiply. So it helps. Please do it like a time in real time better. 4A root 2 like that. And then the next arrow, so I change the color just to signify. Everything from the first bracket must pair exactly once with everything from the other bracket in multiplication. So this green arrow tells me it's still multiplied. If you're not sure, you want to put a bracket also can. If you want to multiply straight away also can. So just emphasize the bracket a bit, because sometimes the terms can be a little bit complicated. So I copy one of it, plus 3 root 2. The other one, when you copy it in the bracket, please put the sign itself with it, like that. So here what we have is negative 18 plus B root 2. Okay, now we just need to simplify all this. So 3A minus 4A root 2. This one is plus 9 root 2. And then this becomes what? Okay, 4 times 3 is 12. Do you all notice that 4 times 3 is 12? Root 2 and root 2, I can just put in a calculator, because at your level they allow a calculator. So either we save 12 times 2, 24. Or you can do manually like how I'm doing. Okay, so then this becomes, negative 18 plus B root 2. So before we can do any comparison, we must always simplify the left-hand side. So let's say we simplify the left-hand side and say, the ones with root 2 must separate from the ones with no root 2. That's the idea of separating here. Not based on whether they got A, the unknown. Like normal equation, there's a little bit of a trick tip. So this 2 has root 2, so we combine these two together. So it becomes 9 minus 4A, and then you factorize out the root 2. I put it at the end so that it's comparable to the given complete surd on the right hand side. So like that, then we equate. This is the step. We equate the terms with first one is without root 2. The term without root 2, this is what we equate here. On the other side, the term with root 2. That means root 2 and without root 2. So if I were to take it exactly as per the colors written there, so I wrote it in different colors, notice. So 3A minus 24 will equal to what? And then the other side, I'm just going to write it in parallel. So 9 minus 4A. With the root 2, you want to write also can. For now, it's okay. Next time, you also drop the root 2 because you can see it easily that we can just cut the root 2 off and just write B on the right-hand side. So equals to B root 2. So both got root 2 means now we just solve like normal. So 3A equals to minus 18 plus 24. So 3A equals to 6. Therefore 6 over 3. The answer is, here is A equals to 2 for this part. Okay, found one number. On the other side, please take note. Okay, let's say we do a bit of cut. Let's cut like that. Because root 2, when you bring over, it's just divide, so you can cut immediately. And you can see that B on the next line is equals to 9 minus 4A. So I just copy that. And then I realized that the A needs to be substituted from this part. This is 2. So it's the part where we use the A. Ta-da! Okay, so by substitution, we can further simplify this as B is 9 minus 8. I'll just put in the calculator if you're not sure. And finally, we arrive at the answer, the integer for the A part. The B is 1. A is 2, B is 1. Thank you. Okay, let's go for the next part. Save the images just in case needed. Okay, let's try 19B. Okay, let's try 19B, please. Third type again. So 3 minus 2 root 3. And this one is 4 plus a root 3, just a similar idea, equals to b minus 23 root 3. Okay, so why are we calculating this? I mean, it's like how to calculate this. Sorry. Okay, so we need to do this carefully. Let's think and see, please. So sometimes accurate calculations. Say we times with this 3 and 4 like that, and 3 and a root 3. That means 3 bracket 4 plus 3 a root 3. I just write a root 3 straight away. Okay, and then on the second one, let's say we do the same way, same style, consistency, multiply by 4 for the bracket, and then minus 2 root 3, a root 3 likewise. Ta-da, the second one. And then this equals to b minus 23 root 3. Oh, okay, let's just calculate this first. So this is 12 plus 3 root 3a. I just changed the order because the unknown is there. Negative 2. Oh, this becomes minus 8 root 3. And then this side one. So each time times. You can put in the calculator if you're not sure, please. Don't take risk. So this is 3 times 2 is 6a. Okay. So this is all equals to, on the other side, I'm just going to change the color a little bit. If you notice, this is like, I write like this first, b minus 23 root 3. Now, since you all already recognized from the earlier question, this can be rewritten as the terms with a and without a. So terms with a, I'm going to write it as 3 root 3 minus 6. Just factorize that, sorry. So it should be a like that. Oh, it's the term with this one lah. Okay, the other side, we're going to write the 12 plus 12 minus 8 root 3. So 12 minus 8 root 3. Okay, being that said, now how do we compare it to the right hand side? So I'm just going to change the color, right? So you'll know which part is which. So the one with the a, okay. If you notice, here they write b, right? How is it even possible? Okay, let's write b, it's okay. Okay, so I just realized that this step, I was trying to link it to a, right? This is a very common pitfall. And then when you put it like this, and then you realize you can't link it. So this is a pitfall. So I was not intentionally doing it. I was unintentionally doing it as well. So I was wrong, in other words. So this is a common mistake. It's okay. Let's just try the common mistake part. So you must not recover from that. Okay, let's say now you see, yeah, this is not actually linking to A, because quite naturally we do algebra. We get that feel of linking it to A. So we need to rewrite this differently. Okay, so we need to rewrite this according to the third 3, because it's a third thing. Oh, so rewrite according to root 3. So I take the terms without root 3. I'm going to write it down now. I see. So I write the 12 minus 8 root 3 at this juncture. I see, and then this side, I change the color and write the other one. I change the color according to the root 3 and no root 3. Yeah, sorry. See, I'm doing still a mistake. I'm copying back the same thing. Okay, it's quite natural when you do algebra a lot. You want to link. That means I'll show the link now visually, so I also don't repeat that mistake. This with this, that with that. The one with root 3 and without. Can you see? That's a common thing. Lah. Because of repetition of doing something, you get to do that in a loop. Okay, this one. And then let's write the other part. Let's change the color and see. So 12 minus 6a, and then we're linking the 3 root 3a minus 8 root 3. Okay, this is the tricks on third, just about this, the same thing will repeat. So this is the part where you write the b, and this is the part where you change the other color to the one with the root 3 and this thing, so you can match it easily. With root 3, without root 3. Okay, let's do the matching, please. So straight away do matching, because you all already know from the earlier example. Okay, 12 minus 6a equals to the brown equals to the brown. Now the blue part equals to the blue part. So 3 root 3a minus 8 root 3 will equals to minus 23 root 3. Oh, then I'm just going to show an easy way of cut, especially on the right one. The root 3 can just divide, because if it's across each term, you can just factor and divide, or just cut, divide by root 3. Something like when you divide by 3 throughout. So we're used to integers, so we don't question that. But when we see root 3, our mind sometimes get a little bit confused. That's the only thing there. The reason why I'm doing the right-hand side, because I see the left-hand side has an A and B. So this is what I call writing in parallel. I don't know which one to do first, but by writing in parallel, I can see more clearly because the left-hand side is 2 unknowns. So definitely we can't solve that first. So we do the right-hand side, 3A minus 8, and this is equals to negative 23. So 3A equals to negative 23 plus 8, or 3A equals to, is it 15? 23 minus 8, huh? Yeah, I think there'll be a lot of jokes on that. Just have to make sure, okay? So A is, then we just divide it. It's the simpler part. It relates to your earlier learnings, and then you get A is negative 5. So this is where we feed back. So put back. So this juncture or step, we put back. Oh, so this becomes 12 minus 6. So in the bracket, we need to put this equals to B like that. So just put back this as negative 5. And then we can calculate it as 12, or just put in the calculator. It's a simple part. I think you can this thing figure out already. B is 42. Done. Thank you. Okay, I'm just going to take a screen grab of the B also. If I do the C. So what you all are seeing today is a bit of the third things. So how to master with third and all that. Sometimes I'll use past years. Sometimes I will bring questions, as I said, people send and all that. So I try to do it in this time, and so I can record it and put it. So in case you miss it, you can ask, you can refer back, or even, you know, if you need to share with someone, you can take it, the video, and share or refer back and all that. Doesn't matter. Okay. So let me just save it here. Okay, what am I doing actually? Oh, sorry. This is done already. Already saved, right? Okay. So let's go for the question C, please. So I'm just going to erase the whole thing. It's a good one. Confused my own stuff. Okay, let's begin. Let's do 19C. Another third example here. So A plus B root 3, and then multiplied by 5 minus 3 root 3 equals to 6 minus 4 root 3. Oh, really, just like. Okay, so how do we figure this out? So similarly as before, this time I just do it in one color. So you'll know already the steps, highlights. So 5 times A minus, so like you're doing already, you're a bit more pro already. So root 3 like that, then you times like that, plus 5B, root 3 like that, and then just arrow. This one times to 3, not sure. Just put root 3 times negative 3 root 3 in the calculator. You'll get negative 9B. Okay, the 3 root 3 times 3 is 9, by the way. So 6 minus 4 root 3. And then here, let's simplify this further, please. Remember, we separate according to root 3. The third itself. 9 minus b is the terms without the third. And then let's write the terms with third, please. Normally write the positive one first. Change the order accordingly for simplicity. So this is root 3. And then here we have, okay, change the same color just to match it easily. So this is 6. And on the other side, this one we change to 4 root 3. So those are the parts that are going to be equal. It's the advantage of this colored thing. So 5a minus 9b, we equate it. No need to write the exam style as I'm writing. Just write a solution like that. You don't need to explain. So we can just write, as long as they see in the answer scheme, they look for what we say. Depends how they design the answer scheme, but generally I'm speaking. Not that I'm marking those papers, but generally I've seen some answer schemes, I think, a little bit I know. So just match it up. They look for key points like that. So until where you're right, you can get the points accordingly. So obviously we cut off the root 3 like that. And then we can write the next step here. 5b minus 3a is equals to negative 4. Okay, this is a simultaneous equation. So you see how it relates to an earlier topic. So looking at the a and b, neither looks easy to directly just, make it same. So no problem. We just times this by 3. Let's say I want to make the a same. So everything I just times throughout by 3. When you do that, you have to do the other side so similarly. So it looks like to make the A same, so 3 times 5. I'm taking the coefficient there and multiplying here. So it's times 5. When they have no common factor, you can do this trick. Sorry, no common easy common factor, like or something equivalent to that. Okay, loosely speaking, so this is 15A, this is minus 27B, this is equal to 18. Please double check in case I calculate anything wrong. 5 times 5, 25B. This is 5, 3, 15A minus, and this is minus 20. Then you can see the part where the one is opposite plus and minus of each other. So you can just do a shortcut by adding these two equations. Okay, so I know that usually you all may do substitution. So let's do a bit of adding differently to learn that it's all the same. You can do it like this, or you can substitute, no problem. You'll still get the same answer. Huh? So I just changed the order of the other one to write the A with the A and the B with the B. So minus 20 like that. So let's just pull this off. Aha. So we're adding, so there's no real bracket needed. So subtract, sometimes I'll write a bracket. And also notice that it's easier for students to understand when you add like that. So you can see vertically, it makes more sense somehow. Okay, the same thing. This plus this or minus, it cancels off. So this plus this minus 27 plus 25 minus 2b. And then this one, just put in calculator, something like a plus sign here. Huh? Please take a look like that. So 18 plus negative 20 minus 2. Okay. So therefore, this means that we can calculate this further. And what can we do? So we write this as B equals to negative 2 over negative 2. Please be careful of the signs. Surprise, you can miss that, but it's okay as long as we understand the general idea of the solution. Okay. So B equals to 1. And then we put back either one of the equation and solve for the value of A. So I put back in 3. Hey, there's no equation 3 there. Okay, I simply want to call this as 3. Just to show sometimes we miss something, you can use that back again. So let's write that, please. So we have 5 bracket, going to substitute that value, minus 3, A equals to negative 4. So at this point, it becomes a bit trivial for most of you. So this is 1. Oh, you can just calculate what? So 3A equals to 5 plus 4. Just rewriting the algebra fast. Or you'll get the 3A is 9. And finally, you arrive the answer for this question also, which is A equals to 3. Thank you. Okay, I'm going to take a screen grab of this, please. Huh? Let's take that. Yep, 19C. Okay, no worries. All right, just what do we say? Let's try to do the next one, please. Huh? Okay. The next one looks a bit more harder than usual, isn't it? I'll show you a different way. All this while you've been doing by multiplying that. I'll show you a completely different way, hopefully. So you'll understand something else about these numbers. Okay, let's begin with 19D, please. So I'm going to demonstrate a slightly different way. The natural way you'll be thinking is that, like doing like that means, most people say just bring the A plus B, root 7 the other side, then you times, and then you can, what we say, you can do the equation like just now, right? Make simultaneous. What if I told you you can do it without doing any simultaneous equation? This one can. You know why this one can and the earlier ones cannot? Actually, C also could have done that way. Some of it have the A and B separated completely within a cert. So I'll demonstrate it to show the technique. So what you do is just rewrite it. So by rewriting, we just switch these two. So when you switch these two, you get something like this. So I just write in the corner here so that you can see that this is 2 plus 4 root 7. Just show the switch part. Huh? Okay, let's switch and see. Why am I switching and how do I know? Because of the entire number is insert. So I can see the left-hand side is now all insert. So I meant. And then on the right-hand side is that unknown, A plus B root 7. So I realized that I can just do an arithmetic count, not algebra. Means purely is in numbers now to do that. Aha, so let's begin. So that means let's compute like this. So A plus B root 7 equals to, let's write this in the same color. So 2 plus 4 root 7 over, 4 minus root 7. Oh, and then the idea goes that you have to rationalize the third, the denominator, because there's no denominator on the left-hand side. That's the logic, over 1, in case you're wondering. So we just put a 4 plus root 7. So 4 plus root 7. Okay, so we're multiplying this 2. Why are we doing that? Because we're going to write it as a, like this times this. So I'm just going to write it a bit more further, just so that it's more clear. It's like this bracket thing, except we're doing it purely in surd and in numbers. Down here, what happens is, because it's the 4 and 4, can you see the a plus b and the a minus b part? So I'm just going to write a bit of a hint on that down below it. So you can see this is the a minus b, rationalizing the surd means a plus b, from which we get a square minus b square. Aha, there we have it, bingo. Okay, so we can understand this step already. So let's continue down here. Need to space right in this style. Huh? So what we're doing is we're multiplying like that, the arrows, remember? So let's multiply the arrows, please. 2 bracket 4, we put 2 bracket root 7, and then the second part is just bracket that. So 4 root 7, okay, 4 root 7 bracket 4, and then 4 root 7 bracket root 7. Aha. So slowly you can put like that. 4 root 7, 4, yep, 4 root 7, 7. Okay, just need to be accurate. It's just testing the accuracy. Then we put it like that. This is 4. So 4 square is 16. Please take note, huh? 4 square is 16. Aha. And then minus 7. Oh, so this is how they simplify. Okay, let's change the numbers a little bit. So I'm going to write right to left. So I'm going to do that for simplicity and depending on the situation. 4 times 2, this becomes 8. And then let's look at the numbers. Aha, the corner one. This one, the corner one. Huh? So root 7, 7 is 7. 7 times 4, 28. If you want to put in a calculator to see that, it's better also to be safe. Huh? Okay, 4, 4, 16 here. 16 plus 2, that means doing this 2. Huh? Oh, it's still root 2. 16 plus 2 is 18 root 7. I see. 18 root 7. And then down there, 16 minus 7 is what? 9. So now we're getting a bit more closer to the answer already. So let's continue, please, on this. What happens? 18 plus 28 is 36. Okay, 36 over 9. So I just split it straight away. Plus 18 root 7 over 9, in case it helps you to think in this way. It's all the same thing. Writing in different forms to show the link. So we get, oh, this is 4. Oh, yeah. This is 7. Aha, this is the one equals to that. A plus b root 7 here. That means, in other words, so a plus b root 7 is equals to 4 plus 2 root 7. I think from this point, you can easily see the answer. Notice I didn't do one simultaneous equation to solve for this one. So you can use by rationalizing the denominator technique when it's purely numerical. Aha, it's a coincidence like that, huh? Let's take note. Okay, so that's how we get the answer. Thank you.